Alrighty, so I'm going to be shaving while I do this. Alright, but I want to talk about this because it was pretty interesting. I was going over one of my engine concept ideas to effectively get around some of the main issues of having way too much power in a motorcycle that just terrifies anyone and everyone. You know what I mean? That kind of thing. So, this one was, obviously, it's a 2-liter inline 6 engine. So let's go over first the manufacturing process of this thing, and then we'll go over all the rest of it. Okay, so the manufacturing process is really rather simple. Okay, this is a cast iron block. Now, the reason why it's technically not fully that, we'll get into. So, it's a standard cast iron that we get from old V8s, flatheads, whatever's out there. That's just huge and really, not being used at all, and they're just a bunch of old stuff that, looks cool at first. Generally speaking, nobody really wants to put in the effort to try and turn into something, and so, a lot of junkyards, pretty cheap material, iron, right? So that's where that initially came from, because then I don't have to go get a bunch more iron from, the ground and tear shit up or any of that stuff. So that's typically where it comes from, is the thought process. But we're not done yet, of course. This is not a standard, regular way of doing things, I guess, possibly. But easily done is what we'll say. The manufacturing is a cast iron, yes, but we're going to have a transmission that's off to, if you were to look at it from the rear towards the front, where because it's for a motorcycle, transmission case is also attached to this off to the left. So the crank case is, of course, below, and instead of making a big block, this is not really going to be that. These are individual sleeves that are attached now to the main crank bottom end. Now, these are going to have carbon, in those sleeve areas that are going to also have either chromium and molybdenum added into them to produce a hardenable and temperable stainless steel. Now, the reason why is because stainless steel is far better at transferring heat. But we're not done, because in order to do that, we can't just put it there, So what's there is like an initial kind of sleeve-ish, but it'll hold that kind of area. We're going to ramrod a ram that's going to have a little bit of graphite powder in that kind of area. We don't want it to stick much. So we then have a big spinning flywheel. This is how I happen to do it. I'm not a big fan of the hydraulic fluid options, because this one's going to be a very specific way of rotating this in to continue keeping heat inside of the cylinder area. That happens to increase, the type of cooling and the relative lack thereof that we were looking for, as we wanted to both be forged into the shape that we're looking for, because there's still a mold around it, but we also don't want it to cool too much, because of course it's quite brittle stuff, standard kind of stuff, right? So we then need to do the other cool guy move of, we're going to let the heat of the engine block cooling off temper the entire process, because now that's cooler, and then of course we're going to let it re-warm back up to do the tempering process, like I was saying. But we're not done fully, because there are other spots for both the crank case, bottom end area here, which we happen to need to use. Instead of one single gear, we have to have 3 gears, but these are the part of the crank connection 5 sided crank thing. I forgot what the hell they're called right now off the top of my head. Point is, those are the bearing areas, right? But it's like, well, fuck this. I'm just going to add in a fucking couple of gears here. They're going to be attached to a transmission gearbox that's going to be placed slightly up and off to the left, which will be wonderful, truthfully. Should work just fine, for what it's worth. Wait a second, I gotta heat up my brush. I use the old style double-edged razor blade because it's supposed to be better for the environment and stuff. Yeah, things like that. Alright, so I'm gonna get that going. I just got out of the shower here. I'm gonna get some beard oil, put it on my face. Turns out that was the big secret. That's my pre-shave oil. That was like the big one. Seemed to change things. Regular high carbon area, steel that's been, forged, quenched, and then treated off the heat of the engine here, and it's mold, sort of pressurized, anything like that. It's just standard, like, I'm just gonna fucking forge it by forcing something in it really hard and, shaping it to what it needs to be shaped as. You're really filling in the gap there. The right necessary amount of pressure and, all that packing stuff. So, that allows for us with a little bit of mixture of that carbon and molybdenum and chromium here, and you have to make hardenable stainless steel, which is not the easiest thing, actually. Hardenable stainless steel is, well, yes, better at a thermal conductivity, not exactly actually easier to make, but can be done, okay? And the rest of it's just regular high carbon, so just put carbon in the area, it gets mixed in, you just allow for it to diffuse in properly, and then squish it to shape. And then, of course, it creates a little bit of steel San Mai technique, basically, where there's iron, regular standard iron, and regular steel in between that then, of course, kind of blends together. Standard forge. It's a good thing in this instance, because that's what we're hoping for. So, this is, after that, not fully done, because of course we still need a little bit more than just a little bit of that. Alright, so, this is where the kind of other part of the movie magic, so to speak, you might end up calling it, happens. So, over here I was casting a aluminum. That's right, this weird, I don't know what this is. What is this? Is aluminum something? I don't know if I can know. But it's a bunch of heat sinks to me. That's literally what it is, but they're not really technically called that, but it's the actual engine block, because this is an engine block right here for what it's worth, but it's like, they don't usually want to call it an engine block, but it is an engine block nevertheless. So, but it's like, alright, so we're going to squish this in there, over top of it, while we get the engine, iron side to cool down just a little bit, and then that's still fairly warm. We put some of the beard oil into the, I'm using Cremo, sheave oil. There's better stuff out there, but, this is what I have, so, if I can deal with it. So, as we do that, we happen to create a lovely little technique of having that almost forged. It's press fit, right? But, it's not good enough. So we have to weld it. So we run with the ramrod still there, and this pressed over top of it, a little bit of electricity through the tube, and then it welds into it, which is great. We just need to get it welded throughout several spots, but we don't want it to ruin its temper, and so we have to do it very spotty-like until we can eventually get the entirety of it fully encapsulated in this, kind of welded kind of style. And then it's done after that. But it's a real cheap, fast way of doing it versus needing to, do way more work to effectively get this fucker to weld or be press fit in or any of these things. It's just a lot more work than you typically would want to try and most likely do. And if you do want to do that, great, super, awesome, go do that. Leave me alone. I don't. I know damn well how much fucking work that would really be. It's a lot of extra work. So instead, that's the first start. This is an offset crank. We're going to be using the iron and some, leftover carbon, probably from some wood area. I don't give a shit, really. We're going to create steel and we're going to forge it, standard parallel style of balance, inline six But of course it's broken into 3 spots here, but then that goes into the transmission off to the top right. Right? So cool stuff. But it's about to get even cooler. This is a super turbo with a generator, which is really just a transmission, but like whatever, to the super part, supercharger, which is a centrifugal style supercharger. Okay, then as a nice little 2 small turbos off to the right. So this is where the intake here is on the left. That is where the transmission would be, except it's actually above that. Then we have a flat style heat exchanger. That's a liquid to water heat exchanger. That is, of course, bolted with the other side of that manifold that goes and exchanges off to that side, which is further away from the engine instead of towards the engine. And it goes up, and it goes down into where the poppet valves are. Right? So, standard poppet valve stuff. Except, actually, kind of not really. We'll get into the engine a little bit more in a little bit. I want to start off with the manufacturing. So, this is, I call them heatsink because it's a dual hybrid liquid and air-cooled system. Which is fine. That's great, actually. That means I can run smaller radiators, except this is a big 2-liter inline 6. That's going to be super turboed and all this other shit. So, typically, we say this, but then we go, I need more cooling. Almost always, no matter what, more. Give me more. We need more. I need way more. Just not more. Give me more. So, these are to come with hyper-eutectic, but then they are, piston connection rods and heads. However, these are not your standard. These happen to be, I guess, kind of like a powder coat. They're in a mold, and then they're still fairly hot. On the inside of that mold, we're going to be putting a very hard material. So this is basically dusted styles of diamond-like carbon and, carbon onion balls. So carbon onion balls are a weird one. They're just recently kind of like a thing where you can make really cheaply. But apparently it's fish scales in a microwave and presto changeo after enough time, and carbon onion balls come out. And the other side of it is effectively another version of plasma deposition to create a diamond-like carbon. When you squish them into a hyper-eutectic, they like to form a silicon, because there's silicon inside of the, aluminum there, that comes out as silicon carbide that then also merges together with the standard aluminum that tends to create also a nice little diamond-like carbon finish with silicon carbide diffusion. These are indeed your pistons. Your piston head and your connecting rods. Mostly because I got kind of tired of trying to change them. It's really kind of just cheap to make them both together as one. Or connection rod, can be both together. But anyways, moving on. It's cheaper to just make it that way altogether versus trying to do this stupid other technique, which tends to cause me to have to separate piston heads versus my connection rods. Now I need a whole separate floor or area inside the manufacturing warehouse to make that happen, which just sucks actually. And so I don't really want to do it. I'm a big not doing, the extra fucking ridiculous work for a small amount of cheap that it creates. It's so little extra cheap. It's actually more expensive to do it for a very long period of time that way. I have to be manufacturing it for just too damn long. So, anyways, moving on. Painted the face, of course. Get that wet again. Alright, nice little double-edged razor blade here. Alright, so that's what it comes with. We got the double wrist pin action here, which normally people tend to not want to, but where they tend to not know about this. But for an offset crank, they help balance the crank such that you don't need to worry about needing to have that imbalance that starts to occur with double wrist pins. They still exist, yes, but it's just less. You don't have to worry about it nearly as much, which is really, really quite nice. Which is why I tend to like them in offset cranks. So, I get hopefully the best of two worlds, or both worlds really. But of course, there's still a little bit of balance, and there's a little bit more complexity, and there's always something that really, realistically, after a while, there is, of course, shockingly, something that is not for nothing. Oh, wow, crazy. You know, yeah, take the good with the bad, as they say, kind of stuff. So, this is where the intake comes in. All right, standard intake stuff. All right.